So we're going to go to our notes. Let's open up the sequences and series note sheet that we were working on before. And we had an arithmetic sequence is kind of where we started. In fact, I'm going to scroll down to where our notes were because they were kind of clearly divided here, in our last class. So arithmetic sequence on the left, geometric sequence on the right. Just to kind of give you a little recap, arithmetic is when we are adding or subtracting something, and geometric is when we're multiplying or dividing something. And so kind of the meat and potatoes of the problems were, if we were trying to find a term given a sequence, we first would determine, okay, is it arithmetic or geometric? If it's arithmetic, then we find the common difference. And then we wrote our formula, and then we solve it, okay? And similar, if it's geometric, we do the same thing. We find our common ratio, and then we write our formula. Oops, sorry, here was our common ratio for that one. Then we write our formula and solve that, okay? Before I move on, does anybody have any questions about that stuff from last night's homework? Or are we feeling okay with that? All right, well then I'm going to do something that may or may not look related, but there's a definite tie-in. So this will be a new section, and this is called sigma notation. All right, sigma is just a Greek letter, but it's scary looking, so students look at it and think it means something really crazy, and it doesn't. Let me give you an example of a problem that you guys will have on your homework. Something like this. Sigma looks like kind of a crazy E. So it looks like that. And you may have seen something, you may have seen that sigma in different places. And it actually sometimes has a little notch on the top and bottom. I'm just too lazy to write that usually, so I just write it like this. So here is sigma notation. We have a couple of numbers that we're going to write around. The number at the bottom is our starting point, and the number at the top is our ending point. So I'm going to say like n equals 2 on the bottom. And on the top, I'm going to write 5. I will, of course, explain what those things mean in just a minute. And then next to it is a formula. So I'm going to write the formula n squared minus 3. All right, so this is what the problem looks like. Okay, it will just show that. Here's what it means. What it means is sigma just means we're going to add a bunch of things together. Okay, so it means summation, it means we're going to add things together. This number is the first number we're going to plug in for n. And then we're going to plug in every integer until we plug in that number. So for example, we're going to start at 2, we're going to plug in 2, then 3, then 4, then 5, and stop there. And then we're going to add all those things up. Okay, so that's what this means. So given this problem, I'm going to take 2 and plug it in for n. So 2 squared is 4, and 4 minus 3 is 1. And then I wrote plus because I'm going to add the next term. So I plugged in a 2. Now I'm going to plug in a 3. So 3 squared is 9, minus 3 is 6. Then I'm going to plug in 4. 4 squared is 16, minus 3 is 13. And then I plug in 5. 5 squared is 25, minus 3 is 22. And now I just want to add those up, and that's my answer. All right, so to add them up, let's see, we got 20, that's 30, 35, 41, 42, right? Make sure I did that correctly. So our answer is 42. So this sigma notation, if I just wrote that by itself, like when I started class, a lot of people look at that and be like, what the heck is that? Okay, so that's the whole point, is don't be intimidated by that. We just need to know what the different symbols mean. This is the first number we plug in. We plug in all integers until we get to this number. Here, of course, is where we're plugging it into. And then the sigma just means add them all up. All right, let's do another example just to make sure you guys have this. So let's do another sigma notation. And let's say n equals, let's go from 0 to 6. We'll make this a little longer sequence or series. And let's make our equation, how about negative 2n plus 10. All right, so all we do is start plugging in numbers starting with 0. So we're going to plug in 0, 1, 2, 3, 4, 5, 6. Then we'll stop at 6, and then we'll add them all up. So plug in 0, negative 2 times 0 is 0, plus 10 is 10. Now we plug in 1. Negative 2 times 1 is negative 2, plus 10 is 8. Now we plug in 2. Negative 2 times 2 is negative 4, plus 10 is 6. Plug in 3, get negative 6, plus 10 is 4. Plug in 4. You know, actually, you might notice that that goes down 2 and down 2 and down 2, right? So the next number is going to be plus 2. Okay. I'll plug in a 5. Negative 2 times 5 is negative 10. Plus 10 is 0. Plug in a 6. Negative 2 times 6 is negative 12. Plus 10 is negative 2. And then I stop, because remember, I'm just plugging in from 0 to 6. And now I just add all of them together. So I've got 10 and 8, that's 18. 18 and 10 more would be 28. I guess those two are going to cancel out. So they add up to be 28. All right, we get the idea on sigma notation. Any questions on that? I'm going to keep going with something else. If you guys are good. You guys at home, just put something in the chat if you want, or yell it out. All right, well, let me kind of change gears, or maybe reverse gears to something that we may have done before we even started this today. So would you guys write this down? Okay, we're going to write the formula. For this sequence. Two, comma 9, comma 16, 23, 30, 37. We want to write the formula for the sequence 2, 9, 16, 23, 30, and 37. So think back to last class. Before we even talked about sigma, erase that from your brain. Is it arithmetic or geometric? What do you guys think? Arithmetic, very good. It's arithmetic because we're going up 7 each time, right? We're adding 7. So when we're writing the formula, we know it's arithmetic. We have our d value is 7. So our formula for arithmetic in terms of n is a sub n equals a sub 1. What's the first term? What is a sub 1? 2, right? So 2 plus n minus 1 times our d, which is 7. So that was a little review of something that we might have done in our homework last time, writing the formula for this sequence. And a sub 1 is the first term. Our d value was 7, so it's n minus 1 times 7. So here's the connection. I want to take that and I want to write that in sigma notation. So this would be kind of worlds colliding. Write in sigma notation. Two plus 9 plus 16 plus 23 plus 30 plus 37. So the same string of numbers that we had up here, I just want to add them all up. Okay, I want to write it in sigma notation, which means, that would be telling the reader to add those up. So here's what we want to do. Of course, we're going to do sigma, right? So let's do that first. And we have our formula, which we just wrote right here. So that's going to be 2. I'm going to put the whole thing in parentheses. 2 plus another parenthesis, n minus 1 times 7. So that's our formula. Remember, we got that from, the previous problem. Now remember, in sigma notation, n is going to go from 1, because that was our first term. And then what goes here is how many terms we have. We have 1, 2, 3, 4, 5, 6. So that is now written in sigma notation. So on your homework, you're going to be asked to do that. The first thing, I think, and you can do it in any order you want, but I think it's easiest to find the equation first, like we did. And then these are always going to start at n equals 1 because we put the first term in the equation. And you can test that by, plug in a 1. 1 minus 1 is 0. 0 times 7 is 0, plus 2 is 2. That's the first term. Plug in a 2. 2 minus 1 is 1, times 7 is 7, plus 2 is 9. That's our second term. Okay? If you plug in a 3, you'll get this. If you plug in a 4, you'll get that. If you plug in a 5, you'll get that. If you plug in a 6, you'll get that. And remember, we're stopping there. All right, let's do one more. All right, so we are going to write in sigma notation. This 3 plus 8 plus 13 plus 18 plus 23 plus 28 plus 33. So let's figure out the equation. Okay, it's arithmetic. What's our value of D? What's our D value? Come on, guys. 5, yeah, so D is 5. So our formula is going to be a sub 1, which is 3, plus n minus 1 times 5. That's going to go in our sigma. So I'm going to do this. I'm going to erase that. Put this guy in a little lasso and move it over here. And I'm going to put my sigma up front of that. Okay? So we want that summation. We have to fill in here and here, though. Okay? So the bottom one is going to be 1. That's the first term. And then the top one is, how many terms do we have? We have 1, 2, 3, 4, 5, 6, 7 terms. So that's going to go on top of the sigma. It's now written in sigma notation. And I didn't solve it, by the way. I didn't do that in the previous one either. It just said to write it in sigma notation. It didn't say solve it or figure out what it is. All right, so we did 2 major things. I mean, the first one was, given the sigma notation, to find the numbers and then find the sum, to actually find the sigma or the summation. And then the second one is to write something in sigma notation. So does anybody have any questions on either of those ideas? Guys ready to be on your own? Okay, so I'm just looking at a question. So why is there a number plugged in for the first one and 7 for the second one? And so these numbers here are the numbers that you would plug into this string or to that equation to generate this string. And so the easy answer where they come from is you always plug in a 1 because that gives you your first term. 1 correlates to the first term. And this is 7 because there are 7 terms. Okay, that's correlating to that guy. So the number of terms goes here, and this is starting at 1. Okay, and you should always be able to check that by, if I plug a 7 into this equation, well, 7 minus 1 is 6. 6 times 5 is 30. And 30 plus 3 is 33. Okay, so that's like the last term in the string. That's where those numbers come from. Good question. Any other questions?